Welcome to Sound and Communications Viewpoint. We're here to talk about digital television transition and the White Spaces initiative. I'm here with Jerry Budge of Blundertongue Labs and Darren Cheshier with SKC. My name is Jay Paul. I'm with AVI-SPL. I'd like to open this up by asking about what is happening with DTV.
Back in 1996 and 1997, the FCC mandated that all off-air analog broadcasts must transition to digital. So the AM VSB amplitude modulated signal has to change to a digital signal, 8 VSB, 8-level vestigial sideband modulation. And the date is 17 February of 2009, right around the corner.
So on 17 February 2009, analog television transmission stops.
For all major broadcast stations, all the analog stations will turn to snow. Anybody relying on those stations will have to make some sort of accommodations to accept that new digital signal and put it back out into their networks. The signal, the digital signal, is more efficient than the analog signal because now where you used to have just one program, you can now have 3 or 4 programs existing in that same channel bandwidth that used to be just one.
Okay, so on a digital television transmission, there is more than one program.
Yes, there can be more than one program if the broadcaster chooses. What used to be a analog signal of 525 lines is now a digital signal. It can be 720 or 1080. This is high definition. The excitement that's caused, brought lots of business to lots of integrators installing high def and updating televisions, etc.
Okay, so we have an improvement in resolution.
Improvement in resolution.
We have the ability to have more programs simultaneously. What's going on with sound in digital transmission?
The sound will go from a typical stereo to a Dolby, say, 5.1 level of audio if the broadcaster chooses to adopt it, but the bandwidth is there to support that increased audio.
Does this decrease the white space availability within each channel?
This actually has created the white spaces because the FCC has taken entire chunks of television stations and forced them to move to a different frequency, thus creating white spaces. But what it creates for the integrator is a challenge in the RF networks of now they have, where they used to have one channel coming in, they now might have 5. So do they want to just take that primary channel and distribute it, or are they going to take all 4 or 5 and distribute them?
Okay.
If they do that, it's going to chew up more of the network bandwidth.
So explain what you mean by taking these multiple channels and distributing them.
Currently, with an analog signal, you use a simple off-air processor or many different demod, remod methods to capture the signal, process it, and put it back out. With digital, you have to make different accommodations because it's no longer analog. All of the analog gear that you can find in schools, prisons, hospitals, anywhere relying on the free off-air signal will not work after 17 February. So different accommodations need to be made.
Okay, so this is for any of us who are integrators who are currently distributing analog over the air. Okay, it's a given. We're going to have to use different equipment to receive and decode. What happens once it's inside the building, once I've decoded?
If you choose to broadcast it back through the network as an analog signal, you will need to prepare the facility in the head end to accept the digital, convert it back to analog, and remodulate it onto a channel of your choice. No changes need to be made to the distribution network, nothing at all there.
Okay.
But in the head end, lots of changes have to happen.
We're going to take a short break from this and resume. We'll talk about white spaces and 700 megahertz. Be right back.